Hello guys, hope you're doing well. And as always, if you're new to my channel, I would humbly request you to subscribe to my channel. Okay, so today we are going to discuss about a very important subject and a topic in maths that is basically number systems, which is being very much frequently used in O levels exams and basically also in IGCSE exams, metric, inter, and almost frequently used in engineering and sciences fields. Okay, so let's start the topic. Okay, regarding the number systems. Okay, so we have basically 14 types of number systems used in maths. Okay, so if you look at it very clearly, the number one is basically natural numbers. Okay, so natural numbers are all those numbers which exist in maths except the value of zero. Okay, it includes 1 to infinity. Okay, so which means that if you want to study about natural numbers, you must know that they must start from 1 and 2, 3, 4, 5, 6, 7, and going up till infinity. So these are all basically natural numbers. Okay, so but basically we will not be considering 0 in the natural numbers. So what numbers we should use if we have to select 0? The answer lies in number 2, which is termed as the whole numbers. Okay, so our whole numbers are those numbers that don't include any fraction or decimal, but they do include 0. Okay, so you do not have any fractions like 1 upon 4 or zero point 0.6 or zero point 0.8, very much similar to natural numbers. But in natural numbers we do not have 0, but when we say whole numbers we will include 0 into it. Okay, so they become the whole numbers. Okay, now the third one category is termed as the integers, and if you look at those integers, they are all whole numbers which are divided into two parts. Okay, so we're talking about whole numbers. Okay, and again we have two parts when defining the integers. We have positive integers and we have negative integers. Okay, so positive and negative integers. Now if you look at it further, uh, positive integers will include 1 to infinity. Okay, so 1, 2, 3, 4 till going to infinity. But the negative integers will include minus 1 to negative infinity. We have two types of infinity, plus infinity and minus infinity. Okay, which is negative infinity. So if the negative integers are considered, we'll start from minus 1, minus 2, minus 3, minus 4, going all the way to negative infinity. Okay, be very careful into it. Basically we will, whenever we consider integers, we will be including 0, but 0 is neither positive nor negative. But remember, 0 is basically going to be considered as an even number. Okay, so it is very important that 0 is an even number, because every time it alternates, number is an even number. Okay, like 1 and 3 are odd, but 2 and 4 are even. Okay, so a very important point here. Now let's start with even numbers. Even numbers are all those numbers which are divisible by 2. Okay, so all those numbers which are divisible by 2 are termed as even, like 2, 4, 6, 8, 10. They are all even numbers. Okay, and remember, 0 is also treated as an even number. Okay, here it is, very important. So now the opposite of even numbers will be the odd numbers. So all those numbers which are not divisible by 2, for example 3, 5, 7, 9, 11, 13, all these numbers, if you look at it, they are not divisible by 2. So they will be coming under the domain of odd numbers. Okay, so I hope you understand till here. Let's go to another number system which are called as the prime number systems. Okay, very important, the prime number systems. Okay, so all those numbers which are divisible by 1 and themselves, for example like 2, 3, 5, 7, 11, 13, 17, they are all being termed as the prime numbers. Okay, if you look at it here, list of prime numbers between 1 and 1000. Okay, so you can say between 1 and 1000, 1 is a prime number, 2, 3, 5, 7, 11, 13, 19, 23, and again look, 233, 239, all these numbers, if you look at it all the way till 1997, they are all basically treated as prime numbers. Okay, they will be divisible by itself or by 1. So these are basically prime numbers. Okay, so So now we basically go to what are basically the perfect squares. Okay, let's go to perfect squares. Perfect squares are those numbers which whose square root is a whole number. Okay, so you will get a whole number whenever you take the square root of it. For example, 1. Okay, so 1 is basically take a square root of 1 is always 1, which is a whole number. Like 4, the square root of 4 is 2. Like 25, the square root of 25 is 5, which is a whole number. 49, the square root of 49 is 7, which is again a whole number. So this is how you understand about the perfect squares, uh, explaining it as whenever you take its square root, it will be a whole number. These are very unique composite numbers. You must take it very carefully. Okay, so composite numbers are all those numbers which are not prime numbers. Okay, which are not prime numbers. For example, apart from the prime numbers, all the numbers will be treated as composite numbers. So, like 4 is basically a composite number. 6 is not a prime number. 8 is not a prime number. 10 is not a prime number. Okay, 15 you can treat it as not a prime number. So these are termed as the uh, composite numbers. Now we go to another number system, which is a rational number systems. Okay, so rational number systems are those numbers which can be converted into fractions. All those numbers which can be converted into fractions are whole number. For example, if you have zero point 0.2, okay, so zero point 0.2, if basically if you take it as take the decimal on the right side, it can be treated as 2 over 10. So you can make it as a fraction equals to 1 upon 5. Similarly, zero point 0.8 can be treated as 4 upon 5. And vice versa, 0.3333 could be written as 1 upon 3. So these are basically the rational numbers. Now, what are irrational numbers? Irrational numbers are counter to the rational numbers, okay? Because these are those numbers which can never be converted into fractions. You can never transform them into fractions. For example, pi. Pi is a value which cannot be converted into a fraction, okay? Or take a square root of 2 or square root of 5, square root of 11. These are all treated as irrational numbers, because if you take square root of 2, it is 1.4142, and the decimals after digits after decimal goes on and on. Okay, so this is treated as irrational numbers. 20 is not the exact value of pi, it is approximately equal to pi. So yes, 22 is not the approximate value, so that is why we treat it as a irrational number. Okay, the value of pi is going to continue. So, okay, so this is how you consider this irrational number system. Now let's go to another system which is called as the fractions. Okay, fractions are proportions are part of a whole number. For example, if we write it as 4 upon 6, 7 upon 8, 1 upon 6, it can be simplified further to 2 upon 3 as these are all fractions. Fractions are divided into two categories: proper fractions and improper fractions. Okay, so now let's see the categories of these two. And if you look at it, the proper fractions are those fractions whose numerator is less than its denominator. For example, 3 upon 6, the 3 is smaller and the denominator is larger. Or 5 upon 6, numerator is small, denominator is large. 7 upon 8, here again the numerator is small and the denominator is large. So it is basically termed as the proper fractions. What about the improper fractions? If you look at the improper fractions, they are those fractions whose numerator is greater than its denominator. For example, 5 upon 2. Okay, find a 5 upon 2, you can see it is the opposite of proper fractions. Here the numerator is larger, the denominator is smaller. So this makes it a improper fraction. Okay, and you can basically transform further this improper fraction into a mixed number. Okay, by dividing 5 and basically 5 divided by 2 will give you a mixed number. Okay, so this is a very important difference between proper fractions and improper fractions, which are further transformed into mixed numbers. Let's go to what are mixed numbers. Okay, mixed number is basically those numbers whose comprise a whole number and a proper fraction. For example, 2 4 upon 6 could be treated as a mixed number. What about this 8 5 upon 6? If you have written found somewhere, you can treat it as a mixed number. Okay. What about the other numbers we have over here? If you look at it, we have real numbers. Okay, so real numbers are all those numbers which do exist. Okay, for example, all above mentioned numbers are real numbers. Okay, all those numbers above are all real numbers. All real numbers can be expressed on a number line. Okay, so all the real numbers can be expressed on a number line system. Okay, remember. And if you look at it further, you can see that this is if you look at it, this figure, okay, you have basically seen it as this is your real numbers. Okay, and within the envelope of this real numbers, we have irrational, we have rational, integers, whole numbers, natural numbers. All those things are basically coming under domain of real numbers. Okay, so this is how you define it as real numbers. And then you have another category of domains which is called as the imaginary numbers. Okay, if you look at these imaginary numbers, you can say these imaginary numbers are those numbers which cannot be expressed on a number line. Okay, any number line we have, we cannot express them on imaginary numbers because they are not present, they do not exist. Okay, they have no presence. They are called and different names. They are also called as complex numbers. So imaginary numbers could be given another name as complex numbers. So all numbers which are not real numbers are imaginary numbers. For example, any number which is a square root within a root, such as square root or cube root, where we can be treated as say minus 2 and minus 5. All these are complex numbers. Okay, and any number with a denominator like 0 is also an imaginary number. Okay, so any number with a denominator 0 will result in an imaginary number whose output will always be equal to infinity. Okay, so we can further elaborate this example as like this. If you go, like if you have square root of minus 2, okay, you can basically consider it as that this value I is basically termed as the iota. We call I as the iota, and this iota is always equals to square root of minus 1. Okay, so for this imaginary number minus 2, we can simplify and write it as this square root of minus 1 into 2, but this minus 1 could be replaced as iota. Okay, so this minus 1 could be replaced as iota, and square root is taken in a separate radical sign. Okay, so and this minus 1 now becomes as iota into square root of 2. So you can write this imaginary or complex number as square root of 2 into iota. Okay, remember the value of iota equals to square root of minus 1. Okay, now the other way of expressing those imaginary numbers, so if you have any basically number which is basically either a natural number or a whole number is divided by 0, then it can be written as, it cannot be solved, and it can be defined as is always equals to infinity. Okay, so this is the sign for infinity and basically symbol. Okay, so be very careful that this I is also called represented as iota. Okay, so this is all what we have for the number systems that we have basically studied till now. Okay, so I hope you have understood the 14 types of number systems that exist in maths. Okay, so I'm very much thankful to you, and I hope you guys have a wonderful day. Thank you.